SpaceX did not want to do water sound suppression, but apparently they are doing it for the next launch.
Yeah, except that Elon Musk's tweet about this said, new water deluge system to protect against the immense heat and force of Starship launch.
Oh.
And I'm...
What?
Like,
Wait.
that's not... Like, so if you're... No, I'm going to offend someone here. I apologize. So, as Josh correctly stated, the water that gets... the massive amounts of water that get shoved under the rocket here at the Cape and elsewhere during a launch is a sound suppression system. It does a little bit to like dampen the flames, right? But for the most part, it's for acoustic vibration that happens when you create these immense launches. It's not adapting I guess that is a force that's created by the acoustic issues, but like anyway, and it's not just for to like cool the flames, right?
Right, yeah.
So like
Cool the flames.
So, yeah. So his tweet about, his ex, what do we call him now?
I don't even know.
About it. We don't call him anything. We don't read him.
I don't know what to do about that whole situation.
Yeah. His post about it made me angry. Because I was like, that's not what they're for. So anyway, yeah.
Welcome to Walkabout the Galaxy, the happy-go-lucky astronomy podcast where the science is universal, the opinions are personal, and the hosts are collectively a nitrobaryon.
Ooh.
Yeah, we are.
With a K?
This is inspired...
Canitro?
Canigitro baryon, inspired by listener Trey Harmon when I asked for the tetraquark.
Thanks, Trey.
Note that if Jim were here, top quark, if Jim were here, we would have it different because a baryon has 3 quarks.
Oh.
An odd number of quarks.
Sure.
3.
We're always an odd number of quarks.
But we are topless today.
We are topless today.
We are Strange, Charm, and Down, the astroquarks, also known as Josh Caldwell.
Addie Dove.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including Facebook, Instagram, and Threads. And since we are topless today, be sure to check us out on YouTube.
Yeah.
But not on Amikumu, Faizanmi, or Traduki.
Dookie.
Traduki. Which one is made up?
So those are all different languages.
Two are real. That's very good.
Thank you. The second one you said it was slightly French accent.
That's also very good.
So either you made it up in French or it is French.
Oh, that one's the fake one.
What was the first one?
Amikumu.
I think that could be... What's the third one?
Traduki.
I want Traduki, but I want it to be real.
So I'm going to say the first one's made up.
And what are you saying?
The third one.
Oh, I got you both.
It's the French one.
The French one is made up. It's actually Haitian Creole. And it's it is the translation for what Amikumu means.
Which is something Creole. Friend?
Yeah.
Well,
make friends, yeah. Fais amis is like faire des amis, but in Haitian Creole.
Oh, fun.
Instead, yeah.
What's the Dookie one?
Traduki is Esperanto for translate.
Oh.
Huh.
And
okay. What's the first one?
And what does it mean?
No, what language is it in?
I don't remember.
Oh. Cool.
That's fun. I'm sorry.
Don't apologize.
You can contact us anytime at wtg@ucf.edu with questions, compliments, and to find out how to get a cool Walkabout t-shirt. Thank you to those of us who have done so. We graciously have loved your compliments and have been delighted to send you Walkabout t-shirts. Our stumper today is ecliptical.
Ooh.
Because we have eclipses coming up.
What? We have what?
Eclipses.
Oh, okay.
I should have said eclipsical.
Eclipsical. Mm-hmm. That sounds tasty. I could use one of those when it's really hot outside.
Yeah, but not right now.
Eclipsical.
There's nothing like a nice
eclipsical.
Cool eclipsical.
Really cools you down.
Which is better, a solar eclipse seen from Earth or a solar eclipse seen from the moon?
Oh, man. I have been trying... So we've been talking about our landing site stuff and how and our cameras field of view and stuff like that for our LunarVise mission.
Addie is co-lead of a mission to the moon.
To the moon. It's going to go to the surface of the moon.
Deal.
It's going to have cameras on the moon And it turns out the sun is also shines on the moon. But
Thank
like,
goodness. Or
which
your
is
cameras
great.
wouldn't
Yeah.
be able to
cameras
see much
wouldn't
of
be able to see
anything.
much. But also, you don't want to point your camera at the sun.
You do
And so
not.
I've been trying to wrap my head around what the sun does in the sky. And it's just I still haven't seen a good. I thought there used to be a good way, a good animation, but I can't find it.
I'm pretty sure it rises and sets, but just
It
slowly.
does. It does it really slowly because it's like 14 of your Earth days
Of your Earth days.
Wow.
is one day on the moon.
From dawn to
From
dusk.
dawn to dusk
Yeah.
on the moon. And so it's very slow, but also like, so we're at like
Yep.
36 degrees
North
latitude,
on the moon.
but the sun is above the equator. Like there's only like a 1 degree
It's not too-
offset between the equator
What-
and the
do
sun's
you know what
ecliptic.
time of year you'll be there?
We
or does it
don't
matter?
really. It doesn't really matter.
Okay.
Yeah, it doesn't really matter because
Okay.
it's the 1 degree, so
Right.
it doesn't really matter.
Oh, nice.
But yeah, so it's pretty
Okay.
high throughout the day, and like most of our site is illuminated throughout the day. But
Right.
like in the morning when we're landing,
Right.
there's going to be really intense shadows.
Local lunar morning.
Yeah.
There will be
But
good
when you're-
shadows
yeah.
for landing, which is good to help you see what you're looking at.
Yes, but also bad because you don't want to land in like a crater or
Right.
something like that. So yeah, but at the South Pole, the sun angle is always really low
Yes.
because the moon doesn't tilt like the Earth. So
Right.
if you're at the South Pole of the moon, the sun's always like
It's like basically on the horizon
it's
all the time.
yeah. So
Yeah.
it's they get really intense angles.
Yeah.
It's gonna be really hard for South Pole missions, but
Yeah.
anyway.
So
But anyway, I've been thinking about that a lot lately. So
Okay.
I'm gonna say moon.
you want to see a solar eclipse from the moon. Is that just because you want to be on the moon?
No, I've seen one here on Earth. I want to see one on the moon.
Okay.
I mean, obviously the moon, because it's on the moon.
Because you want to go to the moon to see it.
Yeah, of course.
It's like you'd rather be collecting garbage on the moon than seeing a solar
Yes.
eclipse on the Earth.
Plus,
Yes.
like,
That's kind of like, okay, but suppose you get to go to the moon anyway.
sure.
Okay, so you get to spend a month on the moon, and you are going to get to see one solar eclipse in your lifetime. Do you want that to be a solar eclipse from the
Moon.
Earth or during your 1 month on the moon?
Moon.
I think on the moon.
Really, why?
Because
I
I don't
would-
know. I already have a really good idea of what a solar eclipse on Earth looks like because I
And they are super phenomenal. And there's really
Yeah.
interesting,
I mean,
like things that happen with nature
yeah.
and stuff when you're here on Earth.
I think
and
the
the
way
light
I-
is way
that's
different.
also true.
With the
But how does
conditions
the
that I
light
put
change
in,
on the moon?
with the conditions I put in, I would stick with the Earth one. If I get to spend
Okay.
a month on the moon anyway. So what's different about them, right? So first from the Earth, the moon is like just right to cover the sun.
Mm-hmm.
So you see the solar
Yeah,
atmosphere.
you get to see sweet.
The Earth is being much bigger than the moon.
Oh, I didn't
When you're
think
on the
about
moon,
that.
It's like
The
a
Earth-
full.
It's
Totally
just-
blots it out, but also it
Oh.
has an atmosphere, so you have sunlight coming through.
How long does an eclipse last?
But that
on
would be
the-
cool to see the
Also
sunlight
the same.
through the
Longer, yeah.
atmosphere. Like,
Yeah, that's
The
what I'm
whole
thinking
way
about.
So
Like,
that would be
really
cool. The
cool.
Earth's atmosphere is going to look very interesting, and then you may have some kind of weird illumination there because you're seeing the sort of
Yeah.
glow from the sunlight
Atmosphere.
refracted through the
Yeah.
atmosphere. But you don't see things like
Do we have LRO?
birds going
We don't see
nuts.
birds. They have LRO data, lunar reconnaissance orbiter data from solar eclipses.
Yeah,
There's really interesting data of like what happens on the lunar. Like people do really interesting thermal measurements of what happens during eclipses
Yeah.
because those are really quick transitions
Right.
relatively. Anyway,
gives you a different time scale to measure how the surface reacts to
Yeah.
heating and cooling. Well, today
Cool.
we'll talk about water in a protoplanetary disk, dark stars, and other news. But first, this episode of Walkabout the Galaxy is brought to you by Eris. E-R-I-S. Hey, it's not my fault for causing all the strife and discord over the definition of planets.
Sure.
That's on you humans. I'm just minding my own business in the outer reaches of the solar system. In fact, I've seen my own share of trouble that got me booted out of the Kuiper Belt and into the scattered disk with the other Kuiper Belt troublemakers. If you want to take a break from all your earthly troubles, consider visiting me on my leisurely 559-year orbit around the Sun that will take you nearly 100 times further from the Earth than the Sun. Eris isn't the source of your problems, it's your safe destination to escape your troubles. Come to Eris. Seek the unexplored.
I don't trust that. Seek the unexplored.
Colorado.
Ooh, I like it.
Because
Montana.
nobody's been to Colorado.
Well, I've seen those commercials
Greenland.
and stuff for.
That's right. There you go.
I like Colorado for that answer, though.
Solomon Islands.
Oh, I would not.
Because
something
nobody's been there.
Zing.
I think maybe fewer people that have been to Colorado. I'm just
that you know
But what
of.
about like per land
True.
capita?
maybe the tourist to resident ratio. Maybe there's something going on there.
Yeah, I
Maybe
want to
that
see
would-
that. I want to see the data.
Yeah. Okay. Well, on space news, I was surprised to see a headline about the water sound suppression system on the super heavy
Mm-hmm.
launch pad for SpaceX
Mm-hmm.
at Boca Chica Starport Base or whatever it's called.
Uh-huh.
So we remember that their first launch of this ginormous rocket, they managed to destroy the launch pad, which may
Yes.
also have partially destroyed the rocket in the process.
Mm-hmm.
And I thought I had seen stories that SpaceX did not want to do water sound suppression, but apparently they are doing it for the next launch.
Yeah, except that Elon Musk's tweet about this said, new water deluge system to protect against the immense heat and force of Starship launch.
Oh.
And I'm
What?
like,
Wait.
that's not like. So if you're, no, I'm gonna offend someone here. I apologize. So, as Josh correctly stated, the water that gets the massive amounts of water that get shoved under the rocket here at the Cape and
Yes.
elsewhere during a launch is a sound suppression system. It does a little bit to like dampen the flames, right? But for the most part, it's for acoustic vibration that happens when you create these immense launches. It's not adapting I guess that is a force that's created by the acoustic issues, but like anyway, and it's not just for to like cool the flames, right?
Right, yeah.
So like
Cool the flames.
so yeah, so his tweet about his ex, what do we call him now?
I don't even know.
About it. We don't call him anything.
I
'Cause
don't
we
know
don't
what
read
to,
them.
I don't know what to do about that whole situation.
His post about it made
There you
me
go.
angry.
Uh,
Because I was like, that's not what they're for. So anyway, yeah, they have some sort of new water suppression system.
yeah.
But like, they don't have trenches.
Right.
They don't have like the rest of the infrastructure. So maybe they're just dumping a big buckets of water. I don't fully understand, but they did test it, and maybe it'll help.
With rockets?
No,
Just the water
dumping
system.
the water.
They,
They
so they
just
can
dump it
successfully
without
dump
water.
water in there.
Without the trenches, where does the water go?
I mean, the trenches are just to direct stuff, but
Well,
like,
right. If they're, I mean,
so
But,
out.
like-
I
Right.
mean, it's a
But
big
is it
open
just-
flat plane. It has plenty of space to go.
Oh my god.
well,
Oh
they're-
no. Oh no.
their launch pad is sort of a pedestal
Okay.
with a hole under. I mean, it's like
Yeah.
a stool, a stool with no seat.
Cool.
Yeah.
So there's some distance between the bottom of the rocket and the ground,
Mm-hmm.
but there's not something that diverts the exhaust in
Out.
any particular
Direction. Yeah.
And some people, and I haven't studied this in detail, but there was some analysis of the video, and you may recall that of the 33 engines or whatever on the first stage, that by the time that test flight ended, 5 or 6 of those engines weren't working, and
Yeah.
some of
Yeah.
them had stopped working very soon.
Yeah, yeah, like
and
right
it may
away.
have been because
They
like
got debris.
Yeah.
debris flew back up from the ground and smacked into those
Yeah, that's what I saw.
engines there. So anyway, that's something that will be interesting to see the next flight. And it plays a very critical role in the whole Artemis project, which I think, you know, we talked about the Space Launch System, NASA's big rocket, and we were very excited to see that go, and we're looking forward to Artemis 2 with people getting a trip around the moon. But the whole plan for landing people on the moon depends on the SpaceX super heavy rocket and this Flash Gordon Starship at the top getting multiple successful test flights first, because they have to make the big rocket work. They have to show that They can do something with Starship
Do
in
they have
space.
to? I think they have to even do a landing first.
Yeah,
before
they
do
have
it
to
with
land
humans.
a
Well, I'd
Starship.
hope so.
Not only
Yeah,
do they have to get
right.
it into orbit, they have to show that they can dock with Gateway. They
they
have
have
to
to get
show
it to
that
the
they
moon.
can get to the surface of the moon in
Right.
for 4 years
Yeah. And
From now?
from now.
Or like from
Sorry.
a year ago, really.
Well, yeah.
And
I
yeah,
mean,
and then
I mean-
fly down to the moon and then take off from the moon and come back. They got to do the whole thing without people. And
Oh my
I'm just
Also, apparently, they don't have a permit for like this water.
right. One of the things from the
There's a CNBC article
EPA.
about it. Yeah.
Yeah, they haven't done their environmental impact study.
Yes.
Tisk, tisk, tisk.
Because they're already in trouble from the previous environmental impact from the previous launch.
Right,
Yeah.
because
So-
stuff went flying all over the place.
Sure did.
So there's a lot of asterisks associated with that part of the Artemis program.
Oh.
Yeah, so I mean, I tell you what, I don't.
It's-
I have
they-
no
I mean-
inside knowledge of this whatsoever,
Yeah.
but it would not surprise me if the first humans back actually are going down on the national team's lander, the Blue Origin, Lockheed Martin.
I
Is
mean,
it Northrop
to be
in
fair,
there?
that has no demonstrated hardware either.
I
But
know.
but they're just developing
just
the lander
like
part,
a
right?
simpler- right.
It's more traditional,
Right.
and it's just the lander part. So they just have to build the thing that somebody else's rocket will take. To
A lot of
somewhere.
rockets could get
And a
it.
lot of rockets
They're
can do
probably
that.
proposing to do it with New Glenn, which hasn't flown yet either.
Yes, but they
which
could
is a
do it
less
with like a
ambitious-
Vulcan potentially or something like that, which also hasn't flown. Man,
Yeah.
space is
Space is
dynamic
hard.
right now.
One of the things that we say a lot in our business,
Space is
usually when one of our things doesn't work, is space is hard. And
hard. Speaking of which,
metaphorically,
show
that's
is.
true.
Well, not really speaking of which. Recently, ISS lost, we were just talking about that.
Yeah.
ISS lost contact with Mission Control, but it was an Earth thing. It was just like a power outage at Houston.
Oh,
Not
wow.
The ISS was fine. Nobody panic.
Electricity.
Although that's
was
one of
hard.
those things
All
that
good.
like starts in a sci-fi drama movie, right?
Right.
Where like the station loses contact with Mission
Yeah.
Control,
Right.
and that's the sign that everyone on Earth has perished.
Right.
And
Yeah.
only the people on the ISS are left.
Yeah. That's a bad
Let's
situation.
put at least 9 people up there.
I'm sorry. Instead of 7 or 6?
Yeah. Just like if the more the merrier.
Just to
get
if
a
the
little
rest
bit
of
more-
Yeah,
civilization
if everyone
goes
else
away.
is gonna die.
Just
Yeah.
a little bit more genetic diversity.
Exactly.
6 won't do it, but 9, we're good to go.
I feel good about 9.
Okay. There's a Comet story
There,
in
yeah.
Space News.
There's a comet heading to the inner solar system right now that is really cool because it has active cryovolcanism on it. Not every comet has volcanism, but this one does. And there was recently a little like eruption, and because of the shape of the comet, it kind of looks like it has horns now.
What's the difference between cryovolcanism and what comets normally do?
Usually what comets do is sublimate, so the stuff on the surface of the nucleus goes from solid to gas
Okay.
and is,
Evaporating.
yeah,
out,
yeah.
From the
It
directly from the
sheds-
surface.
Yeah, it sheds from the surface of the nucleus, and then that's what makes up the coma.
Mhm.
But some comets get warm enough, the interior gets warm enough that it will kind of burst out.
Is there a
Material
liquid
will
phase
burst
involved? Is there a liquid phase
I don't
involved?
actually
Does there have to be
know.
for
I don't think so.
I'm not
cryovolcanism?
sure. I don't think
Just
so.
a
but
more
it's
volatile.
More
Yeah.
volatile and bursty.
Yeah, it's more
and
energetic.
interior-y.
Yeah.
Right. It's so
Yeah.
energetic that some might even call it explosive outgassing.
That's totally.
Which,
Totally.
funny aside, when I was
Oh, is this a Deep Impact
it
reference?
is a Deep Impact story
Okay.
because in the movie Deep Impact, that's some drama you can have with your astronauts on the surface of the comet. Is when the sun rises, you could have these dramatic outgassing events that could cause peril for the astronauts. And they asked me, what is that called? And I said, explosive outgassing. And they thought that sounded too much like a violent fart.
Sure.
Well, it does.
And so
It does.
if you watch the movie carefully, which I encourage you to do, buy your copy, available on Blu-ray.
Oh.
Go to Blockbuster.
At the party before the launch, the astronauts are talking about all the different perils they have to face, and one of them says explosive outgassing, and the other one says, Jim, my kid's here. I feel a personal sense of ownership
With that,
related to
joke.
that particular line
Also,
of dialogue.
can't kids talk about farts?
Yeah, kids talk about farts all the time.
Farts are so funny.
I feel like the better joke would have been like, we're talking about natural events, not your problems, Jim.
That actually is a better
Oh,
line.
there you
You're
go.
welcome.
Missed
World.
opportunity.
Or maybe, and that's just the astronaut.
Yeah,
Or
something like that. Yeah.
But so this comet is called 12P Ponsbrook. And it's actually going to be visible in about a year. It'll be it's closest to Earth in about 1 year, next June.
So this is a relatively unusual. So the 12P, the P means periodic
Yes.
in that nomenclature.
Yeah.
Which means it's a comet that we have seen multiple times, like Halley's Comet is a P comet, a periodic comet.
Mm-hmm.
The 12 means it's a relatively bright one that was, got its numbering early on in the numbering game. And so will we be able to see it with the unaided eye, or will we need...
I think so.
Binocs?
Yes.
Do we need some binocs? Or some
Yeah,
telescopes?
I mean, yeah. I haven't looked into it, but space.com
we
is
have a year to
saying
figure it out.
that
We do.
on June 2nd, 2024, it
Okay.
will be visible in the night sky.
Set your calendar.
So
Okay.
look forward to that.
Great. And it's... Most of the periodic comets that we know, first, they typically are not very showy. And they also are on kind of like asteroid sort of orbits, kind of.
Yeah, some of them are.
But this one is on a 70-year orbit, I believe. Is that right?
Yeah, 71-year
Which
orbit.
is kind of like Halley's Comet, sort of a
Yeah,
once-in-a-lifetime kind of a comet.
Yeah,
So
it's huge.
so that's fun. So hopefully we'll be able to see something with that. Okay. Well, we had, in honor of missing Top Quark, I'm going to give a preview of a story we'll do when he's back, and
Okay.
then we'll do trivia in our stories.
Sure, that sounds
Does that
great.
work? So
a preview.
the preview is just when we were a little peek behind the magic of Walkabout the Galaxy here. When we were
Tune into our Patreon to check that out.
When we were discussing our topics for this episode of Walkabout the Galaxy,
Topless topics.
Top Quark posted a link to an article that says that the universe is 26.7 billion years old.
Oh yeah.
Which is
Actually,
really old.
The article says astrophysicist claims.
That
Yeah.
darn astrophysicist. Is it Abby Loeb?
And which is about twice the age that all the other people besides this astrophysicist are saying. And Jim's comment was just, spoiler alert,
It's not.
it's not.
Is it aliens? Spoiler alert.
So we'll get
It's not.
the down low on what that particular story is on our next episode.
Oh, one more space news thing really fast. There's all this UFO talk again.
Mm-hmm.
And we talked
There
about
is.
this.
They have a new set of
recently.
letters for them, unexplained aerial
Oh yeah,
phenomena.
UAPs, unexplained aerial phenomena.
Yeah.
And there was that congressional testimony recently about it.
Oh,
and I
there
think
was
that
some sort of
person
like
It's just
whistleblower.
There's a whistleblower.
Or so,
yeah.
Self-dubbed
And there's
whistleblower.
but like I don't know. There's a lot of like I heard this person say this thing, and like a lot of the videos have been debunked. And I appreciate that they're capturing this data because there's a lot of like video data from pilots that are like I don't know what I'm seeing, but
Right.
also like they don't always really understand physics and
Or remote sensing. Like sometimes they are remote sensing issues
yeah.
that, you
It
have
just
to be
happens.
really into the instrumentation
Right.
to understand what's going on.
Yes.
Yeah. So like I mean, it would be super awesome. But also, the thing about cover-ups of
Oh.
something like
Yes.
this
That's
is
hard to
just
do.
like that's so hard to do. And I know there are tons of state secrets that like if you have clearance, right, you don't tell people, right?
Right.
There are things that you keep secret that you just don't tell people and that are super important. But like I don't know. This
This
doesn't
one
seem
has been
like
hard to
one
keep
that-
under wraps for 70 or 80 years.
Yeah.
It would be
Or even
really
10
hard.
years.
And also, it would be surprising if it was like, I didn't actually like listen to this congressional hearing, but like if these phenomena are just happening in this country
Yeah.
and not in other
And then
countries,
other
so then it would
countries-
have to be like a multi-country
Conspiracy.
Well, that's why
Conspiracy,
we're
which
not
is like,
talking about
oh
it
my
because we want the
goodness.
tech. We don't want
Right.
other countries to get the tech.
But the aliens are only coming to the United
Yeah.
States. They're
No.
not.
Yeah.
They're not showing up in Uganda.
Right.
They might be.
And,
They're not
but
telling
they're also
us.
very good at keeping
Yeah.
secrets.
Yeah,
too,
exactly.
Right.
Yeah.
Yeah.
All of the countries of the world are just really, really good at keeping secrets about this one thing.
I mean, the other note I'd like to make about the whole UAP business
I do
now
appreciate
is
the renaming, I guess.
it is because
Yeah.
they're not necessarily objects.
No.
And they're not necessarily flying. They're things in
They
the
are
atmosphere.
unidentified, that is
and
still
they're
correct.
unidentified, yeah.
Yeah. Anyway.
Is that we have no interest in covering this up.
Yeah.
Oh, the
Nothing would be
science
better
community.
for
yeah.
us
Yeah.
than an actual confirmed discovery of extraterrestrial life or intelligence.
Yeah.
That's like a large part of the reason many of us are doing this
Yeah,
work
yeah.
And
is
a
to
lot of
find that kind of thing.
Yeah.
Yeah.
You know?
And a lot of the planetary scientists in the field are actively
Actively
doing
looking
that.
for
Yeah,
this,
they're
right.
Astrobiologists.
We want
Yeah.
this.
looking for life. That's like
Yeah.
the whole driving reason for going to Mars these
Right.
days.
Yeah.
Right?
So we're the
It's
last
like
people who
water
would
and
be
life.
covering this up.
Yeah.
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 That's what we want them to think.
Yup. The plot thickens.
Okay. So, well, let me do the trivia on
Yeah,
it
we've
first.
been all over the place this episode.
Okay. Our trivia is planetary,
Yay.
and it's pretty straightforward. And it's related to our sponsor, or our sponsor, I should say, inspired the trivia, because Eris, our sponsor, was the first object discovered in the solar system that was believed at the time to be bigger than Pluto after the other planets had been discovered.
Okay.
It actually is a little bit smaller than Pluto,
Yeah.
but it's
Plot
more
twist.
dense, so it's more massive than Pluto. So that got me thinking
Interesting.
about
What's it made of?
the rankings of these things based on size and radius are not always the same, right? So, and then also, of course, Eris is part of the whole story of like the International Astronomical Union deciding that
Yeah,
to create this new category of object called a dwarf planet.
sure.
And then Eris and Pluto then got put into that category, right? So, how many moons, there you have 3 parts.
In many moons.
How many moons are more massive than Mercury? How many moons are bigger
Ooh,
than
I
Mercury?
feel like that's one I know better. but I'm
And can
gonna
you
get it wrong.
identify them? And how many moons are more massive than Pluto? So those are your 3 trivia questions.
Okay, cool.
And it's bringing to this whole question of like, okay, some moons are in this sort of dwarf planet or
Yeah.
planet
Yeah.
realm based on size or mass.
Yeah.
But because they happen to be orbiting a planet,
They're called a moon.
yeah,
That is in the
Cool.
IAU definition, I think.
Yeah.
that's right. Yeah, you can't.
You have to be not
You have to be the
the
thing,
primary
the
body
thing
or whatever. Yeah.
not the thing orbiting the thing. Yeah.
Yeah.
Okay,
What are
so
we going to talk about next?
we are going to talk
Should we
about.
take a walk through the JWST corridor?
Yes.
Oh, what a good idea.
Let's start with some observations related to what Audrey does with the MIRI.
Oh,
Instrument.
yeah.
Okay.
The
So
observations are not related to anything I do.
No,
but
they're
it's
not. But
Same
done
instrument.
with the instrument
With the
that
instrument.
I have
If
been
you
using.
if you download the if you sponsor us on Patreon, you'll get to see the exciting before the scenes footage of us looking at
Well,
our computers and
about this.
Audrey talking about her data.
So this instrument goes by the acronym MIRI, and there's MRS. Is MRS part of MIRI?
Yeah, MRS is medium resolution spectroscopy.
And it's part of the mid-infrared instrument or
Yeah.
something like that? MIRI?
Yeah,
on
that's
the
exactly. MIRI is the
JWST.
mid-infrared instrument. That's what
Yeah.
it stands for.
And it has different types of observing modes.
Yeah,
So-
medium and low.
So the particular discovery here, this is published in an article in Nature, which is one of the big gets to get an
Yeah.
article in Nature by Parati et al. That came out just this week in Nature, is a discovery of water vapor in the inner portion of a protoplanetary disk around another star.
Ooh, that's exciting.
And we're always excited about water. We
How,
talk about water
how
a
far
lot.
inner?
Oh, I was just going to ask that same thing.
So this the system is called PDS 70, and
It's in the terrestrial planet forming region, is what
Right.
it says in the article.
So this particular system has a big gap in it that they believe has been carved out by a planet, although the planet hasn't been observed through the various techniques that we identify exoplanets.
Sure.
But there we see the disk. So this is what's called a T Tauri star. It's an early star, sort of at the end of its star formation days. So it's accreting material at about 1/10 billionth of the solar mass per year, which
pretty
means
slow.
it would take 10 billion years for it to build up
Another solar mass.
sun-sized star
Whoa.
at its current rate. So it's at the end of its star-forming days. And but it
I'll
still
add
has
that,
this
like,
disk.
so this is a planet-forming disk. It's this really cool thing that we've been able to do with like ALMA telescope
Yes.
and now with JW
You can
to be able to like really make this connection between like observing, because we observe planets through lots of different methods that we've talked about, but also observing these protoplanetary disks as you see the disks in which they're forming, and we're starting to get more and more, so we're seeing this sort of life cycle of evolution, which is super cool.
Yeah. I mean, before ALMA, we were pretty much restricted to unspatially resolved spectra. And then you would
Which
have
just means
to...
you have a spectrum of like a fuzzy blob that is the whole disk.
Right.
It's
you
Yeah.
like
what's
there's
called
something
a point
there.
source.
Yeah.
Yeah, I mean, you're not even sure, you have no idea how big the thing is, and you, by measuring how much energy is coming at different wavelengths, you can say, well, that's not all coming from a star, because a star spectrum looks a certain way, it's got extra stuff
dust,
in the
it's got
infrared, so
stuff.
that's probably dust heating up for whatever. But now we actually have like pictures of these things, which is amazing. But this particular conclusion is based on the very high resolution, high signal to noise spectra measured by JWST of the disk, and they see signatures of both H2O, water, and CO2.
Carbon dioxide.
Well done.
Thank you.
And this is interesting, and they're in close, like kind of 1 AU, same distance from the star that the
That's really close.
Oh,
is. And
that's super close.
yeah, so I'm trying to confirm that in the Nature paper. This is what the news story said. And the temperatures, but it's where you would expect to see terrestrial planets forming. Inside what we refer to as the frost line or the snow line sometimes. So where the temperatures are cool enough for rock vapor to condense into solid dust particles, so you can start building up rocky planets, but too warm for water vapor to condense into snowballs or ice balls to make the really big planets. So it's pretty...
I think it's even closer in than 1 AU. I'm seeing things that are like crazy small numbers, but I'm trying to. So they don't actually see. So one thing with this is it's a spectrum, right?
Yep.
So they're not actually resolving the disk like in the artist's impression. So like we do in ALMA where we see the disks. They're resolving the spectrum, but from the spectrum you can tell what temperature certain things are at, and with those temperatures they estimate where it is in the disk.
Right.
So like. You're like, oh, this thing is 600 degrees. It must be...
So far away from the star.
It must be this far away from the star, versus if it's at, I don't know, 50 degrees, it's probably way, way out in the solar system, which we know there should be water out there. But, like, most of our models say that there shouldn't be water in the inner solar system because it's too darn hot.
Right.
Too hot.
Now, this
Just like here.
particular star, let's see, our best fit... Local thermodynamic equilibrium model of the water emission in the 7 micron region reproduces water rotational lines at 15 microns reasonably well, suggesting that all water emission in the MIRI spectral range originates from inside approximately 0.05
That's what I read.
AU.
That's what you were
read.
reading. And I was like, that's not the right number, is it?
So that's really close in.
That's incredible.
But what we must remember, so an AU, an astronomical unit, is the distance, average distance from the Earth to the Sun. And their observed spectrum is best fit with a slab of gas, 600 Kelvin, with an emitting area of radius 0.047 AU.
Yeah.
That's smaller than the orbit of Mercury.
That's
now,
what-
this star is much cooler
Sure. Oh, that's
than
true. It's
the
like
sun.
It's like an M. No, it's a T Tauri still.
It is on its
Like
way
an
to
M.
becoming an M or a K dwarf.
So it's a cooler star than the sun.
It's considerably
You expect
cooler.
things to be closer in.
But still, 600K is hot for
That's
water.
Very hot for
Yeah.
water.
So
I bet your water boils.
this
600K.
That's right. So this, we've had several episodes and several stories where we're talking about where does the Earth's water come from. There was one recently about some weird isotopic measurement that said it was sort of formed together with the Earth and not brought in from these outside comets. This is in line with that, right?
Yeah.
This is saying the
Yeah.
water is there where the rock dust is, and it can then get incorporated into a terrestrial planet as it forms, and it doesn't need to be brought in by some big impact of a giant icy comet
Right.
like 12P
Like 12P.
linking things.
Yeah, look
over
at
there.
that. Look at that link.
Yeah. So that's interesting and it's exciting, and we're very excited to see JWST doing exciting planetary science
Yeah.
as well. Okay.
In addition to planetary science, we get a lot of information about like JWST doing extragalactic,
Mm-hmm.
I don't know,
Interstellar.
cosmological science.
Yes.
And this article, and it's really sad that maybe we should have saved this for a Top Quark episode, but he
yes.
can help us with it maybe.
We'll just give a sort of
recap.
advanced preview of
Yeah,
this one also.
Yeah.
But it's very cool.
It's very cool. So this article is, there's a new article that just came out in the journal PNAS, which is one of our favorite ones. Proceedings of the Nash.
It's also sad Jim isn't here because
He
loves
loves
that.
one. We get a good giggle out of Jim for that one. But so this is more JW data with, I forget which instrument actually, but it's a part of a survey that's looking for more cosmological things. So it's, now I'm doing terribly because I can't even remember what the survey is called.
That's okay.
But anyway.
PNAS is Proceedings of the National Academy of
Academy of
Sciences, by the
Sciences,
way,
yes.
but there are some humorous, disparaging other explanations for
What?
that. I won't say
I
them.
don't understand. So this article is entitled "Supermassive Dark Star Candidates Seen by JWST."
Dark Star, have you seen that movie?
I haven't. I was just thinking that. I haven't.
And I'm sure Audrey has
No.
not.
Wow, what an assumption.
Yeah.
So this is by some authors who have previously proposed this theory of, or an idea about dark stars.
So what is a dark star?
So it has to do with stars that are powered by dark matter heating rather than nuclear fusion.
This is crazy.
So it's like, so
And
typically,
one of my favorite things
so
ever.
cool.
yeah, and this is why we need James here, Top Quark here, to like talk us through this a little bit more. But like, so they are formed of like hydrogen and helium products, right? But these stars would exist at like the very first stages of stellar evolution, and they would have enough dark matter to have a heating source, and so the dark matter then creates the heating source, and then the hydrogen and helium around them does create some light that we can then detect.
Okay.
And so they can grow up to like millions of solar masses and can get very, very, very bright, but they're like still just hypothesized.
Okay. So the way a normal star works is you have immense overpressure from all the stuff, normal matter, that forces ultimately two protons to fuse together, and one of them becomes a neutron typically, and you pop out a positron and energy, because the particles that result from that fusion have less mass than what went into it, and you get high energy photons coming out. So that's nuclear fusion. The dark star is still mostly what you said, mostly hydrogen
Mostly
and stuff
hydrogen
like
and
that.
helium.
But
That's
you
mostly
have
what there was in the early universe.
you have a
Still
fraction
is.
of dark matter, and the dark matter particles can collide, and they're not presumably electrically repelling each other the way protons are. But when they collide, they do release energy. and that stays inside this glowing clump of stuff, and that energy comes out, sort of makes it glow. But the power is not coming from nuclear fusion; it's coming from the dark matter,
the heating from the dark matter
collisions.
Yeah. And like, so this is an interesting. So they've previously theorized this, proposed this, and so now they're using JWST data and saying, "Ooh, there was a really big lightning bolt." That's not what they were saying. That's what I'm saying. That's saying that some of the data that folks have attributed to some of the really high redshift galaxy candidates. So there's been all these papers that have come out saying, OMG, we see galaxies way further, forming way further back than we think they should have. So like super early in the history of the universe when there shouldn't have been galaxies yet, but there could have been star forming regions and this kind of thing. And potentially that's when these dark stars would exist. So they're saying that their models show that dark stars provide a match for the spectra, so it fits the spectra, and because like the JWST data aren't like resolved, like we were just talking about, they're just point sources. It could be a galaxy or it could be a dark star, like the sort of, as long as it provides basically the same amounts of
it makes more sense
luminosity.
For it to be a dark star because it's just less.
Maybe
you need like less time to make one.
Early in the universe, these hypothesized dark matter candidates, weakly interacting massive particles, or WIMPs, would be self-annihilating at a greater rate than they are now through these collisions.
Diary of a Wimpy Kid is about a kid.
No. So that's exciting. A different sort of star. We've talked about some exotic star types, and this one, it's not proven yet, but it's maybe consistent with the observations that we have to date, so something that we'll keep an eye on.
Yeah.
All right, let's return to the planetary for the trivia.
Okay.
How many moons are more massive than Mercury?
Can we start with radius?
Sure. How many moons are bigger than Mercury?
If you include...
solid surface.
Okay.
4.
4 and...
1.
Okay. Which one do you think, Audrey? In other words, what's the biggest moon in the solar system is another way of answering that question.
I know.
I think like Ganymede and the moon are both bigger than Mercury. No.
Ganymede is what I was thinking, but Titan with
its atmosphere.
It's without the atmosphere.
Yeah,
Without the
so
atmosphere
Ganymede
maybe isn't.
So Ganymede is bigger than Mercury, as is Titan.
Okay, so
even without its atmosphere.
Even without its atmosphere.
It's a smidge bit smaller.
I was close.
Callisto is almost bigger.
Callisto?
Mercury has a radius of 2439 kilometers.
Okay.
Callisto's at 2410, so just a hair smaller.
Close.
Ganymede is 2634. It's the largest moon in the solar system, orbiting Jupiter. Titan, the largest moon of Saturn, is at 2575 for the solid surface. So both of those two moons and almost Callisto are larger than Mercury. Two moons are larger.
What makes our moon? I'm bad at that.
I already forgot the numbers.
Smaller than Mercury, right? Okay. So now, how many of those moons or any are more massive than Mercury?
0. I'm going with none.
1.
It is 0.
Yeah!
I was like, maybe there's one of the smaller ones
small
that's
moon
for
that's
some
crazy
reason
dense.
really dense.
I
don't know.
Yeah. So
No, Mercury's really dense.
Mercury's super dense.
Mercury's very dense, and those moons are mostly rocky, icy,
and
a lot of ice, so their densities are not so high. Finally, how many moons are more massive than Pluto? And I didn't do size. It's not a huge difference there, because if you think about the moons are like icy rocky, Pluto's icy rocky, you're going to get the same kind of answer.
I don't know. Like 6.
10, but I can't name them all.
Addie will get this one.
Yes.
It's 7.
Oh, nice. Okay. So we're in the right ballpark.
Yeah.
Do you want to take a stab at which 7 they are?
Ganymede.
Titan.
Triton?
Ooh, I like Triton.
Yes.
Moon?
Yes.
Moon.
Yeah.
Callisto?
Yes.
Io?
Yes.
Enceladus?
No.
No. Europa?
Yes. Enceladus is tiny.
Tiny, tiny
Oh.
That's one of
baby.
the things that makes it so weird is
It's
that it
so
has
crazy.
geysers from such a tiny little moon.
Oh,
It's
okay.
so
Yeah.
tiny.
It's
Little
like
baby.
Texas-sized.
What? Texas-sized, really?
It's really tiny.
Yeah.
Wow.
I always picture it as the same as Europa because
Not at all.
Not at all.
on posters,
It is
people put them
very-
as the same size.
Yeah.
Next to
It's
each
just the
other.
hazard
Fake
of-
advertising.
Yeah.
Enceladus
advertising.
is
It's so teeny.
just big enough to be a sphere.
Wow.
Yeah.
It's big enough.
So yeah,
I remember that.
7 moons are more massive than Pluto, and 2
Silly
are
Pluto.
bigger than Mercury.
What about Eris?
Eris is more massive than Pluto, but smaller than Pluto. So in these rankings, Eris and
so.
Pluto are like,
Flippy
10th
flop.
and 11th, or 11th
Sure.
and 10th, just depending on which thing you're looking at. But it just sort of goes
mean
to
8th and
show, well, yeah, if you're throwing moons in there, they're like 14th and 15th.
Oh yeah,
Right.
yeah.
Depending on
Yeah.
if you're doing by size.
Right.
So, anyway, it's just interesting, I think, to
Yeah.
bear in mind. It's like a
We
lot
should make
of the.
some posters.
This is why I'm really fond of the term
Yep.
world.
Yeah. Planetary body, but I like world also.
World is nice.
World. If it's a big sphere, if it's a spherical, planetary, solid object, I'm calling it a world.
I think that's why I say planetary body, because I talk
Yeah.
about a lot of things that aren't spherical.
Yeah.
But it's
Yeah,
still a
I call them-
planetary body.
Yeah. I call them bodies too.
Yeah. Well, while it may have felt like the age of the universe suddenly doubled, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy. Catch up on old episodes wherever you get your podcasts. If we're still on Twitter, or whatever it's called, our handle there is...
Do I even need to do this anymore?
Maybe not. Maybe that's what we should change our handle to. Do I even need to do this anymore? At.
Walk
Do I even
underscore-
need to do this anymore?
underscore galaxy.
You can ask us questions via the ancient technology of email at wtg@ucf.edu. Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Kansas City and around the world. Stay cool. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Audrey Martin.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
Pooey.